Namaste, welcome to Pythagoras Academy. This is Vikram Dachapalli. In this video, I am going to discuss three important special cases of head-on collision. These cases are very much useful when you're dealing with problems of collision in competitive exams like JEE or NEET. So let us explore those three cases. Consider head-on collision between M1 and M2 moving with speeds u1 and u2. They collide and get separated with v1 and v2. These are the values of v1 and v2 in terms of m1, m2, u1, u2. I have derived this in the previous video. If you haven't watched that, I'll give the link of that video in the description. You may go through that and come back to this video. So these are the values of v1 and v2. Using this, I am going to formulate three important cases. Case 1, perfectly elastic collision between two identical bodies. What happens if two identical bodies collide and the collision is perfectly elastic? Identical bodies, m1 is equal to m2, that is equal to m. So substitute in this particular equation, v1 is equal to, and because it is perfectly elastic collision, coefficient of restitution is 1. For a perfectly elastic collision, the coefficient of restitution is 1 because velocity of separation is equal to the velocity of approach. So v1 is equal to m minus m into u1 plus 1 into m into u2 by 2m. So I get v1 is equal to, this first term is 0, m minus m is 0, 1 plus 1 is 2, 2m u2 by 2m, which is u2. Similarly, we can find v2. v2 is nothing but m minus 1 into m into u2 plus 1 plus e, that is 2 m u1 by m1 plus m2, that is 2m. v2 is equal to u1. v1 is equal to u2 and v2 is equal to u1. So the conclusion is the bodies exchange their velocities. So whenever you encounter this case where perfectly elastic collision is happening between two identical bodies, you don't have to solve. You can simply apply this logic that the bodies will exchange their velocities. Case 2, a much lighter body collides with a heavier body which is at rest. So say m1 is much less than m2 and m2 is a heavier body which is at rest. So initial speed of m2 is 0, u2 is 0. We shall substitute these conditions in v1 and v2 to get v1 and v2. Because m1 is much less than m2, m1 by m2 is tending to 0. As m2 is much greater than m1, the denominator is much greater than the numerator. So this fraction is tending to 0. This is the approximation that we are going to use. So let us substitute in this v1, that is equal to m1 minus em2 u1, and u2 is 0, the second term is 0, by m1 plus m2. I shall I shall divide numerator and denominator by m2. So it is m1 by m2 minus e into u1 by m1 by m2 plus 1. So that is equal to, numerator is minus eu1 because m1 by m2 is tending to 0, and denominator is 0 plus 1, that is 1. So v1 is equal to eu1 or minus eu1. v2, the first term is 0 because u2 is 0. The second term 1 plus e into m1 u1 by m1 plus m2. If you divide by m2 on numerator and denominator, so this turns out to be m1 by m2 plus 1. The numerator is m1 by m2 into 1 plus e into u1. Because m1 by m2 is tending to 0, this is 0. So the conclusion is the heavier body continues to be at rest, but the lighter body which hits the heavier body with a speed u rebounds, because I have a minus sign here, it rebounds with a speed eu. For example, say a ball is thrown on ground, a ball is falling with a speed u on ground. Then it rebounds with a speed eu, but the ground doesn't move. Ground still stays at rest. So you can apply this case to in a case where a ball is thrown to a wall or a ball is falling on the ground, a lighter body moving with some speed u, hitting a heavier body which is at rest. Nothing happens to heavier body, but the lighter body rebounds with a speed eu. If it is a perfectly elastic collision between the lighter body and heavier body, the lighter body rebounds with same speed. Because there is no loss of energy, it collides. Before collision, the kinetic energy of the lighter body is half mu square. After collision also, the kinetic energy of the lighter body remains half mu square. That is a case of perfectly elastic collision in case 2. Let us go to case 3. A much heavier body collides with a lighter body at rest. So I'll take m1 is much greater than m2. m2 is the lighter body which is at rest, so u2 is 0. I'll substitute these values in v1 and v2. So v1 is equal to m1 minus em2 into u1. The other term is 0 because u2 is 0 by m1 plus m2. Because m1 is much greater than m2, m2 by m1 is a fraction which tends to 0, which is almost 0. Because the denominator is much higher than the numerator. So I am going to use this approximation here. If I divide numerator and denominator by m1, so I get 1 minus e times m2 by m1 into u1 by m1 by m1, that is 1 plus m2 by m1. So I get v1 is equal to, denominator is 1 plus 0, that is 1. The numerator is 1 minus m2 by m1 is 0, so it is u1. v1 is equal to u1. So the heavier body continues to move with the same speed. When I say v1 is equal to u1, the heavier body continues to move with the same speed. What about v2? The u2 is 0, the first term is 0, second term is 1 plus e m1 u1 by m1 plus m2. Let us divide numerator and denominator by m1. So I get 1 plus e into u1 by 1 plus m2 by m1. v2 is equal to 1 plus e into u1. The conclusion is the heavier body continues to move with the same speed, whereas the lighter body, which was at rest initially, gains a speed more than u1, more than heavier body speed. So they never meet again. For example, there is a truck which hits a ball with a speed u. So truck continues to move with the speed u, whereas the ball gains the speed 1 plus e into u, which is more than u. If it is a perfectly elastic collision happening between a heavier body and lighter body, the value of E, coefficient of restitution, is 1. In that case, so the lighter body moves with a speed twice of the heavier body. So the speed becomes 1 plus E, that is 1 plus 1, 2u. The lighter body moves with a double speed. So these are 3 beautiful special cases of head-on collision. These are very useful for competitive exams to quickly solve the questions on collisions. If you have any questions or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and answer your questions. This is Vikram Dachepalli signing off. Namaste.